Hello, young scientists. In this lesson, we're going to kick things off in our topic about weather. This lesson here will be just kind of an introduction. But in our this lesson and in others, we're going to hopefully cover the following topics. We're going to compare and contrast the difference in relationship between climate and weather. We're going to describe how weather happens, how it occurs due to the constant motion of the atmosphere from the energy of the sun that hits our planet. We're going to describe weather conditions that are associated or connected to certain types of frontal boundaries. If you don't know what a weather front is, that's okay. We're going to talk about that. Cold, warm, stationary, and occluded fronts. And the movement of major air masses in the jet stream across North America. We're going to take a look at those as well. And then finally, last kind of main point, we're going to explain how the temperature of the oceans affects the different climates on Earth because of the water in the oceans holding such a large amount of that heat. Weather can be something that's a very complicated process. There are so many variables that are involved, but we're going to kind of take it bit by bit and hopefully break that down in a way that is easy to kind of digest. All right, first real slide here. Weather. Just basic definition about what weather is and what climate is. Weather refers to the conditions of the atmosphere at a given time and place. Okay, we all kind of inherently know what the weather is. You know, we look outside and see what's going on that day, at that moment, at that place. And we know that the weather at our time and at our place is not necessarily the same as some other part of the state or county or some other part around the world. Climate, on the other hand, is an average or long-term. You might think of it as being the long-term weather pattern for a location over many years. Okay, so kind of the type of atmospheric conditions we would expect for that location. And again, we're going to do a whole series on climate too, kind of break that off into its own thing. Weather results from unequal heating of the atmosphere. Humidity and clouds and precipitation are all important weather factors. Humidity is the amount of water vapor in the air. Relative humidity is the percent of water vapor in the air relative or kind of compared to the total amount that the air can hold. The total amount of humidity depends on the temperature. The basic kind of way to think about that is the colder the air is, the less moisture it can hold, the less humidity it can hold. The warmer the air is, the more moisture, the more humidity that air can hold. Here in Michigan, we get to experience high humidity times of the year where the relative humidity is almost near 100%. We usually around June, late May into June, when the air feels real sticky, and you touch things and they almost feel wet, and some of them you can, you feel your paper and it kind of has that wetness to it. That would be a high humidity time of the year for Michigan. Other times of the year, like in the winter, it's colder, and so the air tends to be drier, and that's one of the reasons, not the only, but one of the reasons a lot of us will experience dry noses and even bloody noses in the winter time because of the dry conditions in the atmosphere. Precipitation. Again, precipitation first thing that we usually think of is rain. And precipitation is water that falls from clouds. And that water, though, it can fall as a liquid, but it also can fall in a frozen form. And types of frozen precipitation include snow, sleet, freezing rain, and hail. And again, we are going to get into some of the more complex parts about weather But I think this slide here is a good summary, kind of a basic understanding in summary of what weather, of the reason why we have weather. And it comes down to warm air rises. Rising warm air will eventually cool down. The cooling air changes water vapor to droplets. It can't hold on to that water in its gas form anymore, so it actually changes or condenses into little water droplets. Those droplets can then form clouds, and those clouds, not always, but they can form precipitation. So therefore, knowing if air is rising or sinking is important for predicting future weather conditions. Air pressure tells us if air is rising or sinking. If air is rising, we know that changing weather conditions are on the way. If air is sinking, it's going to tends to be more fair weather. And again, it all kind of goes back to this: the rising and the cooling, whether it's forming droplets or not forming water droplets. And again, that's kind of it for our introduction. We're going to watch the BrainPOP weather animation to kind of get Tim and Wovie's take on weather as well.